Hey guys, welcome back. This is a several part series on where the price of GPX will be in 10 years. And this is a live simulation as we work through and code the entire simulation of all the smart contracts that make up the GoldPesa ecosystem to see how the funds are flowing, how everything moves based on our assumptions, and can give us a good idea of where GoldPesa can be in a few years or in 10 years or even in a year. So last time we were, if you haven't seen the earlier parts, 1, 2, and 3, I would highly suggest going and reviewing those in order so you can kind of go through our thought process. Definitely like this video. It helps us a lot, so we appreciate that. And we will keep going with our logic. So now we want to continue with this, and we are now going to build all of the components so that we can get the Pawn Smart contract fully working and all of the funds are flowing in the GPX, the GPO, the dollars in the right ecosystem so that we can simulate this. So now let's move forward to the GoldPesa Vault. So the GoldPesa Vault was created as a mechanism so GPO holders can stake their GPO inside of the vault and systematically convert your GPO into GPX on a one-to-one basis every time there is GPX inside of the Pawn Smart contract. Because as we saw here, one of the features of the Pawn Smart contract and what it does is it effectively facilitates the conversion of GPO into GPX. So let's go over here, have a look at our Pawn Smart GoldPesa Vault smart contract. So if you look at the smart contract, it's effectively a staking smart contract which allows you to stake a minimum of 10 GPOs inside of the GoldPesa Vault, and it allows it to convert into GPX regularly. And in essence, what we want to do so we want to convert that. Okay. So this is a smart contract. Of course, when on blockchain, you have a number of different things that are there, but we're going to break it down and simplify it so that we can simulate what is happening inside of the vault. So the next thing we're going to do here is we are going to create a GP. We'll call it GoldPesa Vault because that's what it's called. What we're going to do is we're going to call it inside of the vault we are definitely going to have an address. Let's copy that. It's going to be called GoldPesa Vault. Then we are going to have so we have a vault, and then the job of the vault is going to mainly be to convert GPO into GPX. So we're going to have a function called and if you look at our smart contracts, we have a function here which effectively takes GPX and sends GPO back. on a one-to-one basis. So it converts GPO to GPX. So convert GPO to GPX, which is exactly this function. And what ends up happening is we are going to call GPX. Oh, we're gonna here go import GPX. So I think we need to have a GPX. Okay, so we're gonna have that. GPX and GPO is going to be there. So we're going to have an instance of both. And what happens is GPX will come in. We're going to do transfer from the spender to this address, the GPX amount. So we're gonna have to put the spender in here, GPX amount in here. So we're gonna transfer GPX from the spender to this contract, the GoldPesa Vault. Then we're going to transfer GPO from the GoldPesa Vault to the spender. So GPO transfer address to spender, same amount. Just to be clear, we can, because it's one to, we can just do this just to be particular. This code is clear. We're saying that we're going to transfer from the spender to this address the amount of GPX that is going to be converted, and then we are going to, we can just say amount here. Actually, let's just be clear, GPX amount. And then GPO amount is the same as GPX on a one-to-one basis, so there'll be no fee or no charge in this case. And then we're going to transfer GPO from this GoldPesa Vault back to the spender, and we'll just call this GPO amount just so it's clear. So effectively, we are simulating this exact part of the GoldPesa smart contract, which is a GoldPesa Vault smart contract. And at the end of calling this function, the one thing that we may want to be sure of is we could just grab this, because we want to make sure that the spender is got to be the pawn smart contract. Now, we can call the pawn smart contract, which we haven't built just yet. Actually, have we? Oh, we have here. So we can. Sorry, I keep thinking different. Import. We haven't done this yet, but what we can say is the spender must be pawn. So is the pawn smart contract. So the only smart contract or robot that is allowed to call this function, which in this case we allow it to be called from by anybody, which might not be a good thing. So we might want to just put in here to do where only the pawn smart contract can call this. So initially I done it as, actually I did it as anyone, because if anyone wants to go and convert their GPX into GPO, that we would just allow that to happen. Something to think about. Normally the GPO is only allowed to be converted to GPX, but if somebody were to do it in reverse, would we want to allow that? I think that's something that we can think about. Maybe we'll put a note here. Anybody convert their GPO or GPX into GPO. Most of the time you wouldn't want to do this because theoretically the GPX price will be trading much higher than GPO, but you never know. It's a free market. Anything can happen, and GPO could end up flying really, really high because of the fact that it's built for whales. And whales come in and buy a big amount and could be sending the price of GPO higher, in which case GPX holders may want to convert back to GPO, but for now we're going to assume that we're not going to allow that. So we will also put in here to do here that ensure only the pawn smart contract can call this function. So we'll do that for later. All right. So now we'll just keep it like that because that's the way it operates. So now the spender must be the pawn smart contract, otherwise it raises an exception and says invalid. Transfers GPX from the pawn to this address for this amount, and then transfers GPO to there. So really, this is what the vault is doing at any given time. It is simply just converting GPX to GPO. Okay, so the GPO vault is done. We'll go to the simulations. We'll just create instance of the GoldPesa Vault. GoldPesa Vault equals GoldPesa Vault like that. Oops, I got imported here. GPX and GPO are the only thing that we insert, and we have now an instance of this. Okay, so we're slowly building out our ecosystem. Save that. All right. Now we've built that, and now we want to create the pawn AI algorithm as well. Even though it's an external contract, what we will do is we don't need to create a contract for that, because what happens is the pawn profits that are generated by GoldPesa's proprietary AI market making algorithm, those profits are transferred into the pawn smart contract, and so it's an external wallet technically. So what we can do here is we can maybe just define in the simulations external wallets. So we can say here, we could say, I don't know, user A. In this case, we can just say pawn AI just for now. So you can see here 0x transfer some USDC. Contract address USDC dot transfer, right? USDC address to pawn. We don't even need this. We can just do it like this. So what we're doing is we're transferring some USDC into the pawn AI wallet address to simulate, you know, some dollars that are coming in from external, which is what makes GoldPesa so unique, is the profit that is being generated by the pawn. And what we're doing is we're simulating, saying, okay, well, if we had, let's say, even for now, we'll put $100,000 inside of there, which will slowly enter the ecosystem every single month as we generate profit and add dollars to our ecosystem. So we don't need to create a entire contract just for that. Okay, so that's done, that's done, that's done, that's done. Okay, now we just need the pawn smart contract, which, as we saw here, has these functions here. So we've created a pawn smart contract here, which has 0x pawn, and we can just put this here. Just comment so that we can see exactly what this thing does, right? All right. So this thing collects 0.25% fee anytime GPX is bought, sold, or transferred. And we've done that previously inside of the GPX contract. So we take the pawn here and we deliver 0.25% to it every single time, which we've done here. In this case here, we've also put it into the GPX hooks contract, which also delivers that here before swap, which we did here, and sends it here as 0.25%. So 0.25% in dollars is going into the pawn smart contract. So 0.25 is anytime in fee in USDC, enters USDC anytime GPX spot sold or transferred. Okay, then what happens inside of this contract, if we go over here, we can see that every hour this is what happens, right? We have an hourly routine. So what we can do here is we can just simulate this hourly routine called hourly routine, in which case it's just like that. And what we're going to do is we're going to make sure that this hourly routine is executed. Second. So this is executed once every hour. And what we do is we do three things here. We swap USDC for GPO, or sorry, for GPX, right? Then we swap GPX for GPO, and then we swap GPO for USDC. This is the routine that takes place every hour, which is the main thing. So what we've done is we've got a swap USDC for all right, so what we're doing here, okay, so what we want to do here is create the, just for now, swap C, right? This is going to be swap USDC for GPX. Okay. Now we're going to do the swap GPX GPO. And then you're going to do the swap GPO for USDC. All right. And that's that. Okay. So the first one, what we want to do to simulate this is, the way we've done it is we've said, okay, get a random USDC amount. So what we can do is we want to go here, just like that. Just like that. Okay, so what I'm gonna do. So we're gonna import random there. Right, and we can do. So. We're deciding to choose a random number between 1 and the balance of this contract address. So let's just check here for a minute that the pawn needs to have a instance of USDC. Okay, first of all, so the pawn needs to have instance of GPO, GPX, USDC, Vault. Okay, that's it for now. So GPO. I'll just assign these here. Import these as well, so we're going to go from So what we want to do is we want to know the random USDC amount. So USDC dot let's just do this. Get the USDC balance inside this contract. So balance of this address here. So we get the USDC balance inside this smart contract. Now we get a random USDC amount, as you can see, get random USDC amount. So we're taking the balance, so we'll call it USDC balance. Right. And then we'll take that divided by 1,000. take the total balance in dollars, divide it by 1,000, get a random amount, right? Then what we want to do is we need to get the current price information. What we want to do is we want to effectively ensure that if the pawn smart contract is buying in this given hour, that we do not have a price impact of more than 0.5% on the price, right? So what we want to do is we want to first find out the total balance of dollars inside of the pawn smart contract, divide that by 1,000, find some random number between 1 and that number. Now this is the theoretical price, this is a theoretical amount that we effectively want to buy, right? So if we look at this, okay, so then what happens is, before we get the current price, so what we're trying to do now is we are now going to use a formula, which is this here. This is the formula for Uniswap v4 that is most important. So if we take the total USDC, which is Y, and we add it to this amount of USDC here inside of the liquidity pool for GPX, then we are going to determine what the total liquidity is given the current price, and then we can then determine what price impact this is going to have every time we make a buy order, right? So the best way to do this is we will follow the exact thing here. We're going to get the current price, the GPX pool. So in order to get that, then we can grab the price from pool manager, gives us the price. No, we can get it from pool. So we have the current tick for this pool. Price to tick. Okay, let's write down our steps. Get the current price, and then what we're going to do is get the liquidity. We're going to calculate the square root of price after the swap. Then we're going to calculate the price impact as a percentage, and then we are going to define a threshold, and then we are going to determine the price that limits price impact to threshold. In this case, 0.5% is the max price impact that the pawn should have on any time it buys the token using profits. And then let's just get these things first. So now what we're going to do, let's zoom out here so it's easier to work with this. All right. So when we want to get the current price, we have the pool, and the pool keeps track of the current tick of the pool. So if we look at that, then we need to access that pool. So we could probably access it from the pool manager liquidity, remove, swap, get pool here. So that has the pool ID. And that gives us, can get the price of a given pool. So first we need we can use this function here. Okay, we need to import math. Get price. So what we do need is we need the pool manager. It's not there yet, so we need to okay, so the smart contracts is done a bit different, but in this case, for the sake of our thing, we can do this. Oops. Alright. Okay, so now what we're trying to do is we are getting a proposed our USDC swap amount. Alright. Yes, random USDC amount. Actually, so we'll just call it the same. Otherwise, USDC amount. So now I want to get the current price. So what we want to do is we want to get the current price of the GPX USDC pool, which means that we're going to get GPX price, which equals a pool manager. Oops. Actually, pool manager dot get price. We need pool ID, which is GPX USDC. Okay, so that gets the current price. Then what we want to do is we want to get the square root of the current price. Square root GPX price. Okay, so that's that. Then what we want to do is we have to obtain the liquidity, which is this amount here. So liquidity is equal to the total number of USDC inside the pool. So okay, so that is that way of doing it, because it has a helper function. Okay, so what we need to check is the pool manager. We should have a get liquidity function here. It's just easier. So get the liquidity of a given pool. Get lower tick, get upper tick, get balances, pool track rebounds. So what we can do is put a helper function here that says get liquidity. So grabs the pool. Pool does not exist. Now to get the liquidity, we changes there's a liquidity product here. So we can probably create a property. Okay, total liquidity in the pool. So it returns the liquidity as a property. Okay, so that means that now the pool manager can simply return self and return the pool dot liquidity. So it gets the liquidity for the given pool. All right. So go back here, and what we want to do is we want to grab that liquidity. Pool manager dot get liquidity. So we're going to make sure that that's the, we'll just put pool ID here. GPX pool ID. Refer to it many times. Okay, so we're getting the US dollar total balance inside of the Pawn smart contract. We're getting a random USDC amount that is between 1 and the current balance divided by 1,000, which is what we've used. Then we get the current price of the GPX USDC pool. Then we get the square root of the current price, which is important for all V3 calculations. Now we want to grab the liquidity, so square root of price. So we got the current price. So we got the pool manager. Get price, grabs the pool. The pool doesn't exist. It returns 1.01 to the power of the tick of the pool, which we've discussed. That grabs that. Square root of price. Okay, then it gets the liquidity from the pool. Okay, now it calculates the square root of price after the swap. Square root price after the swap. So get next square root price. So what's happening here is effectively when you add the dollars inside of Uniswap, you are adding more of Y. So if you look at this properly, then if you're adding more of Y and the liquidity stays the same, what's the price, right? So what we want to do is we want to obtain, right, we did this fairly well before in our contract. Right, let's just grab these. We'll do it again. So PA, PB, right? So what we can do is we need to get the lower tick value of the GPX pool. So that's lower tick equals Lower tick is the pool manager. I think we have a function to get the lower tick here. And lower tick. Okay. So we got the lower tick, which creates that, and that will give us that. Okay, don't need that. We're solving for that. So we get the lower tick, then we get the square root of the price, square root of the lower tick, which is PA. Then we want to get the price to the swap. So what we're going to do, so we look at this here, is we've got this square root of price here with the lower tick. So let's just do it step by step. Let's get rid of the gets. Alright, so now we've got, okay, so we've got the lower tick. So now we want the square root of the lower tick. So we got the lower tick, alright. Square root. So the lower tick of the square root price, so we've got PA. So we've got this, and we've got the new Y. So random USDC. Here we should put theoretical balance. After swapping random USDC amount. So now we got to get the balance inside of that hook. So what we can do is we actually have here get balances. So it returns the balances of the pool. Inside the liquidity pool. Okay, so we can just do it like this. Current GPX balance. Okay, so we have the current GPX, okay, so theoretical USDC balance after swapping, so which means we're going to be putting dollars inside. So we take the current USDC balance, which is already inside of the pool. We add the random USDC amount. Now this is the theoretical USDC balance inside the pool after the swap. So now what we can do is, if we want to get the price, which is this here, we effectively want to find Y over L. So we're going to get the price, we're going to find theoretical USDC balance, which is Y, divided by liquidity, right? So this is your theoretical USDC balance after your liquidity is the same, so that's there. plus the square root of PA. This is going to be the price, GPX price after swap, GPX square root price okay. We'll get rid of some of this stuff after. So now what we want to do is we want to say, okay, so square root of price B, I'm going to say, okay, so now we know the square root of price after. So now we want to calculate the price impact. So we're going to have price impact equals I guess whether we do a square root or not. Actually, that's not good. So we need to do a to-do here. Need to make sure here. Let's just make it super clean. So if we have the square root of price after the swap minus, because the price is obviously going to go up when you're buying, minus the current square root of the price, right? Square root of the price divided by the square root of the price, right? That's the price impact. And then we're saying that if so we're going to define the threshold, which is price impact threshold, which is 0.5%, and then we've got to determine price after. Okay, so what we're gonna do is we're gonna say square root price x96c. We'll just use the same thing actually. We should have just used the same thing before. Let's just use the same thing before. Even though it's not x96. Just for the sake of this. Price impact threshold's the same. Price impact's the same, square root price B is the same, liquidity is the same, square root price A currently. Just clean this up. Or determinant square root. Okay. So what we have done now is we are basically simulating the exact contract that's in the pawn smart contract to swap USDC for GPX. And what we've decided in our logic is that we're going to take the total balance of, we're doing this first thing here. So this way we can call this function swap USDC for GPX as the first thing, right? And then when we call this every hour, it's going to first do this. And what it's going to do is it's going to take the total USDC balance inside of the pawn smart contract. So it takes the USDC balance inside of this contract. It finds a random USDC value from 1 to the total balance divided by 1,000. So that finds some random value in there. Get the current balance of GPX and USDC inside of the GPX USDC pool, which is our liquidity pool, which is actually like this pool manager. So in the pool manager, we can say this should be underscore pool manager. Okay, so now we've got the balances, and if we go into the pool manager, we can see there's a get balances, which gives us the token 0, token 1 balance of the pool with the pool ID. And so if we go out to here, we go pool manager, get balances, enter the pool ID, which we know is GPX USDC pool ID. We're just going to make sure that's correct. GPX USDC, yep. Okay, then we're going to output the GPX balance and the USDC balance. So that's going to give us the GPX balance and the USDC balance. Fine. And then we're going to find out what the theoretical USDC balance would be inside the pool after swapping the calculated random USDC. So we add that to that and we get our theoretical USDC balance. And then we'll take a second here. And then we will find the current price of GPX USDC, which is current GPX price, which is the pool manager. We get the price, called get price, gets the pool ID, takes the 1.001 to the power of the number of ticks where the pool is at, which gives us the price. So we get the price, then we want to find the square root of the current price. So we take the current price, find the square root of that. To get the liquidity, we've called the get liquidity function, which we created inside the pool manager, and get liquidity is here, and we can see that the pool keeps track of the liquidity as a global variable inside of the pool itself. That liquidity is only changed every time we add liquidity, because liquidity stays the same throughout the lifespan, and we do change that. So if liquidity is set here as liquidity, so we grab that liquidity. Then we have the lower tick value of GPX USDC. So lower tick is equal to the pool manager. We get the lower tick. The lower tick is the bottom end of the range in Uniswap v4. Grab the pool, grab the lower tick. Then, as you know, with the lower tick here, which is PA is the lower tick, Y is USDC, in this case X is GPX, liquidity is a constant. This price at the square root price at the lower tick is also a constant, and then we are inputting, we get liquidity, so we've got liquidity, then lower tick value. Okay, we've got the get lower tick, so we got the lower tick, and in this case it just gives us the tick value of the lower tick, which means we've got to turn that lower tick into a price. So calculate the square root price of the lower tick. So we take 1.001 to the power of lower tick and then take the square root of that, and that gives us the square root of PA, which is this price here. And then we get the price after the swap. And so that price after the swap is calculated by taking the theoretical USDC balance, which is Y, we divide it by the liquidity, right, which is here. And then we obviously take that to the other side, basic grade 2 math, and we add the square root of PA, which gives us the new square root price of B. Then if we look at the price impact of that, then we're saying, okay, if we take square root price B minus the square root price A divided by the square root price A, gives us the price impact. And then if the price impact threshold we're saying is 0.5%, so what we're trying to determine is that if the pawn were to execute a buy order using the US dollars that it has and choosing a random USDC amount, is the price impact going to be greater than 0.5%? right? So we're finding the max price, which we've called square root price x96c, which is taking the price and timesing it by 1005 divided by 1000, which is a 0.5% greater. And we are just taking the solidity code here, and we've got here price impact is greater than this, then we do this, else it's saying do something else. So instead here, we will just swap USDC to GPX, which we can then do. And when the pawn is swapping, we can figure that out in a second here. Otherwise, what we do is we want to calculate the max USDC amount to swap to stay within the, within the 0.5% impact. So we're basically saying if the price impact of the one that we've chosen is greater than the threshold, then we're going to find out how much max USDC that we can swap. And so to do that, what we are trying to do is we have now the square root of the price. We know the liquidity already. That's already given above. So if we know the liquidity, we need to determine how much Y, which is how much the total amount of USDC inside of the pool to get to the new price. So what we're going to do is we're going to say new max amount. Okay, so what we're going to do is we're going to take the liquidity, we're going to multiply it by the square root price C, right, minus PA. That gives us that. This is going to give us that. So now if we do new max USDC inside pool, then what we can do is a max amount of USDC to stop. So then what we can do is we can get the new max US swap amount. Just make it really just big. Just comment everything. New max USDC swap amount. I don't know. Alright, so we get that value, which is there, that's in there, minus the current USDC balance. Okay. So this tells me how much max USDC I can buy in order to stay under 0.5% price impact given our range, given the amount of tokens that are in the pool. And then, so we've got our new, now we got to get a new random amount because we want to stay within our thing. So new random amount, get new random amount. Okay, and then we want to swap USDC to GPX for this amount. So what we will do is we will we're going to call the swap function. So in this case, what's going to happen is whenever we call a swap, we call the swap v2, which is to USDC to GPX. So we usually just call this, right? So pool manager swap. Now what we're doing is we're swapping from this address 0x pawn, right, to the pool ID. We're going from USDC to this amount. And then we're going to swap that amount. So that's going to happen there. So pool manager vault. All right. All right. So now we're going to do the same here. From swapping from this to the GPX pool ID false, and this time it's going to be not the new random USDC because that doesn't exist here. It's going to be random USDC amount, right, which is random USDC amount, yeah. All right. So we have simulated the first of 3 things that are going to happen inside of the Pawn Smart contract, which is swap USDC for GPX. And you can see that the logic we're using is to take the total dollars divided by 1,000, find a random number. If that number of USDC it buys creates a max impact greater than 0.5%, we find the max USDC that we can buy for that 0.5%, calculate a new random number between 1 and that number, swap that amount, and that happens every single hour when the pawn is instructed to buy GPX using USDC. So what we're going to do is we will pause there and we will implement the swap GPX for GPO in the next part, and we will swap GPO for USDC after that, so we can completely simulate what the Pawn Smart contract is doing. So that's it for this part, and we will see you on the next section.